Hi everyone, this is the introduction to chapter 7, capacitance. So in this chapter we are going to consider an electronic device called a capacitor. So the capacitor basically in most of the time is simply two metal plates that are really close together and they are able to transfer current without touching just by induction. So if you were to charge one of the sides or you push some electron on one of the plate, it will, by induction, push the other electron away. So it is a very interesting device, and there's two main functions where we can use a capacitor in electronic circuit. So first, it acts as a mini battery. Because we are storing charge, if we remove the battery or the power source, the charge will go back the other way around and it will serve as a mini battery in this case. Also, it is really good to filter out interference. We will see later on actually in the last chapter of this semester, we will be dealing with alternative current. And alternative current is able to pass right through a capacitor almost as if it was a normal wire, but direct current cannot. So that can be a very interesting property. Let's say if you want to listen to radio wave, you can filter out the unwanted interference. So the frequency that you're not interested in, you can filter them out. All right, so there's a couple of concepts we need to understand in order to solve some problem related to capacitor. First, this is the capacitor symbol in a circuit. It's simply two plate. Note, if we were to charge a capacitor, after some time, it will have the same voltage as our power source. So we can imagine, let's say, V, and there's a certain time. It does not charge instantaneously. It takes some time to charge. Now we are going to consider in this diagram, if the time is to infinity, well, the voltage here will be equal. They will both share the same voltage. One interesting aspect here is that once we charge a capacitor, the voltage drop and drop and drop until the voltage on the capacitor is the same as the voltage of the power source, but in reverse order. Notice the two plus are facing each other, the two minus are facing each other. The force on the capacitor counteract the force from the power source, and there is no current. We will see some example of how we can apply this. By the way, and again, we will talk about this in the last few examples of this chapter, but once, let's say we have a switch and we open the current or the link between the power source and the capacitor, at time zero, it is like a wire. The current will flow as if there was no capacitor. So we'll see the detail in the RC circuit section. All right, so we are going to talk about a new type, a new value, which is called the capacitance. So it's a value related to the capacitor. It's in the unit farad, capital F. And basically, the capacitance is how much charge can a given capacitor accumulate for a given voltage. All right? So the better the capacitance, the more charge it can accumulate for the same voltage. Second point we need to consider, in some question we will be talking about parallel plate capacitor. This is the most common type of capacitor, and basically the capacitance can be defined as the area multiplied by epsilon 0 divided by the distance between the two plates. Again, we will be solving some example regarding that one. The third point is just like in the series circuit and parallel circuit using resistor, there will be a way to have an equivalent capacitor. So if we have three capacitors in series, for example, if we want to find the equivalent capacitor, we use this formula. It is really similar to the parallel resistor equation. Actually, it is the same. We just replace the capacitor for the resistance. We can also do the same thing when the capacitors are in parallel. When they are in parallel, they add up to each other, all right? So the equivalent capacitance is C1 plus C2 plus C3. Now, if we go back to this formula over here, the parallel plate capacitance, putting the capacitor in series is equivalent to increasing the distance between the initial and final plate. So because we place them in series one after the other, the capacitance has a tendency to lower. In parallel, we place them in parallel to each other, it's equivalent to increasing the area. So we increase the total capacitance. All right? So that's it for the first introduction. In the next introduction, we're going to talk about the important property when we are charging and discharging a capacitor. And after that, we are going to tackle some example regarding capacitor. All right, see you in the next video.